welcome to another 3 steps to sketch on function transformations. In this video, we're going to be looking at the transformation of a square function, and specifically, we're looking at y equals -1/2 x plus 3 squared minus 1. And we'll use our table method to do this. Keep in mind there are so many different ways that you could graph a quadratic function, but particularly in this video, we're looking at how do we do this as a transformation of the parent function, y equals x squared. All right, so here's our reminder of our equation. And here is our outline for 3 steps to sketch. So we will first start by analyzing the transformations. All right, and remember these are transformations on the parent function, y equals x squared. Okay, so if you even want to go ahead and put your parent points, remember this is the graph that's shaped generally like a U, and our main points, the points closest to the origin, are -1, 1, 0, 0, and 1, 1. Okay, so now we can analyze these transformations. So we'll find any horizontal transformations in with the x, and so we have this x plus 3. Remember, with horizontal transformations, you want to think about solving order for applying these. So it's simple enough. Just think x plus 3 equals 0. And what would I do to solve this? And that will get you on the right track for describing your horizontal transformations. So of course here we would subtract 3, which means we are subtracting 3 from all our x's, or that moves our graph left 3. Okay. And this is our first and only transformation for horizontal. Okay, so our x's are moved left 3. All right, now we can look at our vertical transformations. So that's everything else basically. We have this -1/2 out front and this -1 in the back. Okay, so remember we should apply vertical transformations in PEMDAS order. So multiplication will come before subtraction. And we kind of have 2 transformations going on here. The negative also reflects this graph vertically. So that's going to be over the x-axis. We can go ahead and do this transformation at the same time as the 1/2, which is actually compressing our graph vertically. Okay, so we're going to note that this is a compression of 1/2 and a reflection over the x-axis. So basically, we are going to multiply all our y values by -1/2, and that will accomplish both of those transformations. Okay, then saving the easy one for last, that -1, we will do just what that looks like. We will take away 1 from all our y's. Okay, and that will shift down 1 if you want to describe it that way. All right, so we have all of our transformations organized and analyzed, and we are ready to transform in our table. So let's start by creating a horizontal column. We know we're going to be taking 3 away from all our x's, and let's go ahead and do that. So each of our x's minus 3. So we have -4, -3, and -2. All right, and those are our horizontal transformations done. And now we'll have 2 columns for our vertical transformations. So we'll first have this -1/2 times our y's, and then from there we'll subtract 1. All right, so first multiply by -1/2, and keep in mind this does reflect and compress at the same time. So we have a new value, -1/2, 0, and another -1/2. All right, and now all we have to do is move this intermediate set of values down 1, or subtract 1 from these numbers. So we'll have -3/2, or -1/2. We'll have -1 and another -3/2. All right, and this table method is great because once you've applied your transformations in the table, your points are actually found, your final points, in the outer columns. So you can see you have a point -4, -3 halves, -3, -1, and -2, -3 halves. So we can go ahead and plot those and sketch our graph. Step 3. All right, so plotting our first point, -4, -3 halves, -3, -1, and -2, -3 halves. So keep in mind our original graph was the U graph, and because we've flipped it vertically, it should now be an upside down U. Okay. Another thing you can see, knowing different features of your graph can be really helpful. You see the symmetry here, so you should feel very confident that this graph is accurate. All right, so that was graphing a transformation of a square function using 3 steps to sketch and